Today, we'll cover some of the top database issues that we've hit in production over the last several months. So, databases are often a problem. In development environment, you have limited data. Oftentimes, you're running a single instance. While when you go to production, you go to multiple instances, you scale your database, you have real-world traffic, and a lot of the issues show up in development that are not caught that show up in production that are not caught in development or testing. So let's start with the first of the three issues we'll cover. The first one is excessive database locks. So let's look at this SQL statement. Insert into an aggregation table, and then there's a subquery. Select count from another table that is grouped by, so this query generates multiple rows, which are then inserted into the software count. Let's look at the picture. So what happens here is this count, it has to look at the entire index of this table. So entire index, we're assuming the value being counted is indexed. So it has to process the whole index. Then the execution engine tells it to do the insert. And this insert could potentially be large. So if you have a large insert, and this table is large, what happens is that this table gets locked, and no other writes can happen to this table. Let's go back to the SQL statement. Right, this host software table gets locked. And if the lock is several seconds, in our case, we had a different table, slightly more complex query, but the lock was about 30 seconds. And other writes couldn't come in during that time. And it was obvious from the performance reports because we saw the lock time spike when this type of query was occurring. So how do we fix this? Well, first of all, one easy way to fix this is to separate the writing part and the reading part. So we can do the select on a replica, and then we can do insert on the master. Now, of course, there is a trade-off. If we do select and the insert separately, right, the data that's being selected could have updated by the time the insert happens, right? So that is kind of the risk you have to take when your databases are distributed. And as a general advice, when you're dealing with a master database, try not to do read queries from the master. After all, that is what the read replicas are for. Of course, the second issue is directly related to that, and that is read after write consistency. So in read after write consistency, let's say your backend does a write to the database, and then it immediately does a read. But it's not getting this data that was written. It was getting some old data that was still in the replica. So basically, you write something and you read the old data. Well, that's because there's a lag here, the synchronization lag. In one of our production environments, this lag was pretty small. It was under 30 milliseconds. But this largely depends on how much traffic is being hit and kind of what hardware resources are being used and how these databases are configured. And this lag does get worse if the master or the read replica are really busy. So what can we do about this lag? Well, the simplest solution is after writing, instead of reading from the replica, you basically read from the master. That's a simple solution. The problem is it adds additional load to the master. But let's see how we handle this. So in our backend database, we basically have a special value that we store in the context that gets passed around all the methods. So in that context, we say, okay, future database operations using this context always use the primary. But what if you did not want to go with the solution? Right? What if this read was really expensive? You know, kind of like the query that we showed in the previous example, right? What if it was this query that you didn't really want to run on the master? Well, another way to deal with this is to try to read the same data that was written, right? This application knows what was being written. The data is over here. Now it tries to read back and it tries to compare these two. And what exactly are you going to be comparing? Well, you can pick something to compare, or you can just compare the timestamp. Right? You can have an updated at timestamp, and then when reading, you look at that timestamp. I do want to mention one note regarding MySQL. Is in MySQL, the timestamp defaults to 1 second precision. Because if you want additional precision, you have to specify it when you create the column. So if you want millisecond precision, you have to specify it up ahead. I mean, 1 second is pretty large. Definitely not sufficient for critical data. All right, let's move on to our third issue, which has to do with SQL indexes. So what is a SQL index? Well, just to summarize, a SQL index is basically a sorted data structure that is hopefully much less than your large table. And in that sorted data structure, it points back to the rows of the original table. And this index in this example is just an index of a single row, but you can combine multiple rows to create your index. And so this having an index speeds up read operations, especially if you're looking for a specific value or you're looking to do a kind of a sorted operation that uses the index column for its sorting. So what issue did we hit? So the issue that we hit was that the index size is limited, right? This uses a binary tree, so it can only be of a certain size before it stops working. So for example, a MySQL size of an index is 3072 bytes. And of course, the exact number of characters or whatever your index is based on is kind of determinant of how the data is stored. So in our case, I'll show you the table that had this issue. So we had an issue with this software table where, we were gathering up software and we wanted to make sure every, name, version, etc. was unique. But we were using this varchar 255, using this Unicode encoding for bytes. So you can imagine 255, pretty soon, and each one's 4 bytes. Pretty soon we ran out of index space. So the way we solved it is we created a new column called a checksum column. It basically calculates the checksum off of the columns that we wanted to be part of a unique index. And now that became our new index. And basically that covers the database gotchas. So we covered excessive database locks, read after write consistency, and some index limitations, specifically the large size.